Page 319, Lesson 6.2 is on drawing inferences from data. So we're going to look at information and we're going to draw inferences. We're going to kind of come up with conclusions and things. So on 319, the students in Miss Miller's class cast their votes in the school-wide vote for which color to paint the cafeteria walls. Based on the data, what might you conclude about how the rest of the school will vote? So if you look at these, some of these colors will maybe jump out at you a little bit. So it looks like we got a lot of red votes here first. So there end up being 7 red votes. Blue's got quite a bit also. Actually, blue has 12. And the other ones don't have so many. Orange has 4. Green has 4. And yellow has 3. So based off of this, we might look at this and we might say it looks like blue would get the most votes and then red would have the second most votes. So this would be a possible conclusion that we could make. One thing about it though, if we look and think back to what we did in the previous section, we talked about whether there was a good sample or not, whether we have a representative sample. So if you think about this, if you count up all those, there's actually 30 different people, 30 students that voted. So I don't know how big the whole school is, but the other thing is they only asked, if you look back at the question, they only asked the students in Mrs. Miller's class. So they're only asking people in one class. And so it's probably not really the best sample that we could get. So you could say your conclusion would be that you can't make a conclusion because it's not a representative sample. So example 1, Sasha is trying to convince her mother to change her bedtime on school nights. She gathers data on the average number of hours of sleep that a random sample of 7th grade students in her school get each night. Will Sasha be able to convince her mother to let her go to bed later? And the answer, regardless of the information, is probably not. Here's the information. So you can see she is getting 9.5 hours of sleep. And if you look at the information here, she collected the data and then she's describing the data. So about half the dots are between 9 and 9.5 hours. 9.5 hours has the most dots. And then the range is 2 1/4 hours. So with about half of the numbers really close to the amount of sleep she got. Also 9.5 was the mode here. Not looking too promising to convince a change in bedtime. So then step 2, the book's drawing a curve here so we can see the shape of this. And you can see it's a little bit more dots towards the right side maybe than the left side. So more people on the high end of getting sleep than the low end. So another reason why probably not going to convince any change here. So an inference, if they ask us to make an inference is a conclusion made by interpreting the data. So Sasha can infer that about half of the 7th graders in her school get between 9 and 9.5 hours of sleep. So she will probably not be able to convince her mother to let her go to bed later. On the try it, Dash collects data on the hair lengths of a random sample of 7th grade boys in his school. So the first thing they're asking us to look for clusters. Clusters is where we have a lot of data. We have a lot of numbers. So they've actually kind of helped us out a little bit here, you might notice. And so the clusters we have, the first cluster would be between 1/2 and 2 inches. That's this part here. And then the second cluster over here is between 3.5 and 4.5 inches. So Dash can infer from the data that 7th grade boys in his school have both short and long hair. Quick review before we continue with example 2. Just a couple definitions here. One is the mean is sometimes called the average. To find the mean, you're going to add all the numbers together and then divide by how many numbers there are. The median is the middle number or average of 2 middle numbers after you put the numbers in order. So for this problem, technically, on example 2, it says Sasha's friend Margot suggests Sasha calculate the mean and median of the data to determine whether they support her previous inferences about the population. Okay, for the mean, she would actually have to add up all those times and then divide by how many numbers there are. So there are 25 numbers total, so you'd have to add all those together and then divide by 25. And the mean comes out to be about 9 hours and 16 minutes. The median, after we've got them in order, it's either the middle number or the average of the 2 middle numbers. So if there's 25 numbers altogether, that means 12 on each side. The 13th number would be the median. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and there is the median. And you might argue, well, how do you know to start at the top or the bottom? And the answer is it doesn't matter. So if you had started at the bottom, it still would have been 9 1/4 for the median. So an inference is valid if it's based on a representative sample and there are enough data to support it. Basically, then, a valid inference, we have to ask the right people and ask enough people. If we don't ask enough people, it may not represent everybody. And if we don't ask the right people, if we ask people that are going to be biased a certain way, then that's not going to be a good sample either. And then if we do have a valid inference, then it's likely to be true about the population. So it's kind of like what we talked about in the last lesson. You know, if we have a good sample, then it's going to be representative of the population. If we have a valid inference, it's going to be true about the entire population as well. And so mean and median support Sasha's inference that 7th graders get an average of 9 to 9.5 hours of sleep each night. On example 3, they have a box plot, and we've done these before, but that was last year maybe. So first of all, box plots or box and whisker plots. Each section contains about 25% of the data. So for this problem, Margot and Ravi are also trying to get their parents to let them stay up later. They collect data about the number of hours of sleep a random sample of 7th graders get each night. The two box plots show their data. Do Margot's and Ravi's data support Sasha's inference about the number of hours of sleep that 7th graders get? So one thing we can look at is if each section contains 25% of the data, if we had 2 sections on one side and 2 sections on the other side, that'd be 50% on each side, and that would mean that we have the median. So the median actually is where the 2 boxes meet. You might remember from last year. And so the median for both people happens to be 9 1/4 hours. What that means is half the people get less than that, half the people get more. So it's really kind of a good measure of center for us. So they're asking, do these data support Sasha's inference? And so they said the median is 9 1/4 in both of these samples, but based on the box plots, Margot and Ravi can infer that less than half of 7th graders get between 9 and 9.5 hours of sleep each night. So these data do not support Sasha's inference. Okay, this is kind of the book's interpretation of this, and I think this is debatable. Like I said, I think with the 9 1/4 being right in the middle, I think it actually does kind of support her inference. So I kind of disagree a little bit here. And that's one thing about some of the problems in this section is it's possible actually to have 2 different opinions or 2 different answers. There's not really always a clear-cut answer with some of the stuff in this section. So on the Try It, Alexis surveys 3 different samples of 20 students selected randomly from the population of 492 students in the 7th grade about their choice for class president. In each sample, Elijah receives the fewest votes. Alexis infers that Elijah will not win the election. Is her inference valid, and explain? So kind of the question again is, did we ask enough people and did we ask the right people? So it does say these people were selected randomly. Three different samples of 20 students each, so they've asked a total of 60 students out of 492. Again, it doesn't seem like a whole lot in comparison in some ways, but I mean, it's about 1/8 of the people, so you could argue, well, there's still 7/8 or so of the people that we didn't ask. Again, this one could go either way. The book says yes, her inference is supported by 3 different random samples from the same population that show the same data. So they're saying all these samples are showing the same information, so yes, she has a valid inference. Again, I would argue that potentially you could also say no, because not enough students were asked. Okay, and this is kind of the thing where I don't know how they do this with the election stuff sometimes. You know, they have these projected winners. Sometimes they have whatever percent of the people have voted has been reported, and then they're already projecting who the winner is going to be. I don't really get how all that exactly works, but anyway, apparently if it's random stuff, then sometimes that can be actually a valid inference. So again, I'm going to say either way I would accept on this problem though.